Hello, pre-calculus students. Today we're going to go over some more proving identities, and this is from page 10 of our worksheet. Page 10 of our worksheet, if you want to take a quick snapshot of what problems we're going to be doing. We had you do these problems in class in your notebook, and this is the video solution. So if you have any questions on what we did to do each one of them, just fast forward through this video to the problem that you're interested in looking at. So here we go. The first problem, it says prove that cosecant squared minus 1 over cosine of x is equal to cosecant squared of x. So my first step would be to use an identity for cosecant squared of x minus 1. That is the identity shown to the right. If I just solve for cotangent squared of x, you see that you have cosecant squared of x minus 1. So I'm going to make that trig substitution. So the numerator is going to be replaced with cotangent squared of x over cosine squared of x. And my reason is trig substitution. And that is a Pythagorean identity. So my next step is I'm going to turn this into the cotangent squared of x. I'm going to turn that into cosine squared of x over sine squared of x, all over the original cosine squared of x. So I have a compound fraction. My reason for step 2 is I used a reciprocal, not a reciprocal, my bad, a quotient identity. Substitution. Now the cosine in the numerator here cancels with this cosine squared, so they cancel, and the reason for this is numerators cancel, or cross-canceling fractions, like numerators cancel, and my end result would be 1 over sine squared of x, and I'm finally at my last step, where I can say that is equal to cosecant squared of x, and that reason is a reciprocal identity. So that's the end of the first problem. Let's take a look at the next problem. It says sine squared of x times cosine of x times secant of x can all equal 1 minus cosine squared of x. Well, so when looking at this, I'm going to work on the left side, and I have sine squared of x, and I'm going to just do a simple substitution. For secant of x, I'm going to write that as 1 over cosine of x. And my reason for that is a reciprocal identity. My second step is I'm going to be at sine squared of x, because these two cancel out, and that would be cross-canceling fractions or division. And then I'm going to replace 1 minus sine squared of x with the 1 minus cosine squared of x using the Pythagorean identity. So that checks out with that. Moving on to the third one. I'm going to work with the left side, and I'm going to replace sine squared of x with 1 minus cosine squared of x. The reason, I'm just trying this out, I'm going to see if I can make this work. The reason for this is I have Pythagorean identity. There are other ways to do this. You could work with the right side as well, but I'm going to use this. My next step is I'm going to change cosine squared of x to 1 over, or 1 minus 1 over secant squared of x. And the reason for that is I used a reciprocal identity. So that checks out with that. I'm on to page for the fourth identity. Now this one is sine of a plus cosine of a squared should equal this. This one is going to take a little bit of a while to get through. I'm going to work on the left side. I think I'm going to FOIL that out. So I'm going to just FOIL it out, but I'm going to pause the video, and while I do that to save time on the video. Okay, so I FOILed out this binomial, and you can see that the first times the first is sine squared of A, the inner is sine cosine, the outer is cosine sine, and the last is cosine times cosine. So the first reason is foiling. Now I'm going to collect cosine of A and sine of A together, and I'm going to use a Pythagorean identity for that. So that's going to be 1. They're going to, with sine squared of A plus cosine squared of A, make 1. Plus, these two are going to go together. I'm going to have 2 cosine of A sine of A. I'm going to pause the video and work on my next step. Okay, in my next step, what I did was I used a reciprocal identity, and I changed sine of A and cosine of A. I put them in the bottom as secant of A, cosecant of A. The reason for this is I see that in my answer, I'm trying to get to secants and cosecants. So this was just the only way I thought I could do this. So I just transformed a cosine of A and sine of A to secant and cosecant. So that's a reciprocal identity I used. And now my fourth step is going to be add fractions. So when I add the fractions, my common denominator for the 1 is going to be secant of A cosecant of A over secant of A cosecant of A. And I'm going to add that to 2 plus secant of A cosecant of A. And now since I have the same denominator, I can just add them together. So I have secant of A cosecant of A plus 2 in the numerator all over secant of A cosecant of A in the denominator. And if we zoom out, we'll see that we either have it or we're almost there. You can see here just that the 2 and the secant of A terms are switched. So I can switch them in my last step by using the commutative property. So my last step is going to be to rewrite the numerator as 2 plus secant of A cosecant of A all over secant of A cosecant of A, and that would be the commutative property. And that checks out with what I originally started with. Next one. Okay, this one is pretty easy. This one I'm going to work with the left side because the right side's pretty barren. So I'm just going to use some trig substitution. For reciprocal identity, quotient identity. So when I use quotient identity, and now I have, remember I have plus the cosine squared of A. So now my cosines cancel, and in my next step, it's sine squared of A plus cosine squared of A from here. And that's just from cross canceling. And my last step is that equals 1, and this is Pythagorean identity. Well, I hope that video has helped you for 1 through 5. I'll put another part up for part 6, for number 6, because that one's a little bit more difficult and it will take me past the 10-minute point with this video. So hopefully these 5 solutions have helped you, and I will be sharing with you the 6th solution on video as soon as I get a chance to do that. So hope that this has helped, and I look forward to hearing your comments.